me see what I can do to get the show on the road. Now, on Thursday, I did talk a little bit about this 5.2, but I'm going to start afresh because um, I want to make sure we get this in, because 5.2 is really not a whole lot new, because you remember, what was it in chapter 2, what we're talking about, like terms, adding and subtracting? Well, that's what this is. So essentially, it's not a whole lot in regards to new. It's just doing it in a new place or with a new um, type of numbering system. And in this case, it's these polynomials. All right, so 5.2 is called addition and subtraction of polynomials. Okay, so that means what we're going to do is add and subtract, pretty much just like we have been with things that are alike. And you just have to realize that there are some things that are alike and some things are not. And we really have already covered that in chapter 2. It's just now we've got, instead of just having x's and y's, now we got x squares and x's and x cubes and that type of thing. For the most part, that's the highest we ever get. And those are going to make up the bulk of what we're looking at through the rest of the semester, using that type of equation, as we'll see in the next chapter. So let's see. I was trying to handle something before I forgot about it. Let me go back to that calendar. All right. I just want to make sure we had that the midterm exam was in a good spot to see. All right. So let's go back over to this thing here. All right. As I said, is this chapter 5.2 is just about collecting like terms. So what we've got there, it says find the sum, and hopefully by now you know sum means add. But all we're going to do when we sum is essentially take this first thing, the 6x cubed plus 5x plus 7, and then add to it the 8x squared minus 9x minus 1. Now, if it were me, and I were writing this out, what I would do is I would just drop those parentheses and say collect like terms. But they're kind of showing you how to match them up, which is important. So let's just kind of look. Notice that on the left side, you got a 6x cubed. And on the right side, you don't have a like term that matches that. You've got an 8x squared. So remember, those two things are not alike. So we can't put those things together. All right. So what we got to do is we got to pay attention to that. So what they do is they just bring the 6x cubed down and put it in parentheses by itself, because there's nothing else that matches that. Same thing with the 8x squared here. They're going to bring it down and put it together because there's not one on the left side that matches it. And then they go over to the 5x here. Maybe I want to get my little marker. And the 5x and the 9x are like terms, and so they put them here together. All right. Now, that's 5x minus 9x. We always got to get the signs right. So 5x take away 9x is negative 4x. And then lastly, the constant terms, the ones without the variables, 7 and negative 1 right there. 7 negative 1 is 6. So the 6x cubed comes down because it didn't have anybody to meet up with. It brings the 8x squared down. It doesn't have one like it. And then these two come to be negative 4x, and that one comes to be 6. All right. Any questions about that? The way I would describe it, if I was going to say to do this with adding, when you're adding those two things in parentheses, you can essentially just drop the parentheses and then collect like terms. Now, difference or subtraction, you got to do something important before you collect your like terms. When you're subtracting, we got to remember subtraction, unlike addition, it's not commutative. In other words, we can't turn it around. 6 minus 2 is not the same as 2 minus 6. It's going to be just the opposite. So it's important that when we subtract, we've got to pass this negative sign along to every one of those four terms. All right. So I like how they did it here. As it is, I would have just dropped the parentheses and put an extra step in there myself and then collect like terms. But anyway, so that's negative 10x cubed, negative of a negative 4x squared, which is positive 4x squared, negative of a negative 7x, which is positive 7x, and negative of a positive 11 is negative 11. Now we can just collect like terms. See, this one and that one are alike. This one and that one are alike. These two are alike. And the last one, each one of these, they have one that to match up with. All right, now they take them and they put them in the respective parentheses so you can see better what you're putting together. 16x cubed minus 10x cubed is going to give you 6x cubed positive. The 5x squared plus the 4x squared is 9x squared. Negative 6x plus 7x is positive x. And then 7 minus 11 is negative 4. There we got it. So essentially all it is collecting like terms. All right, any questions about how that works?
Yes.
Mm-hmm.
Can you explain this one more time?
What do you want
This
me to explain? What part?
because you said and then you go to the other side with the 10x cubed minus 4 squared. Why are you switching it to
Because
from minus to plus?
subtracting. We're subtracting. When you subtract something, you're changing the sign.
Mm-hmm.
Look at this. See? 10 minus 4 is 6. I'm just making up numbers here now. But 10 minus a minus 4 is 10 plus 4. Like I said, this is not a new concept. This is back what we're doing way back in chapter 1 and 2 with remember what we call it integers, adding, subtracting integers. Those are the same rules there. That's not changed any at all. Okay? These things still apply. See, 10 minus 4 is 6, but 10 minus a minus 4 is 10 plus 4. See, we're still doing that same thing that comes back to chapter 1 and chapter 2. And that's why I said is if you can do chapter 5, you know, you're essentially able to do 10 and 1 because you're doing the exact same things here. You're just doing them in a different context. So see what's happening here is the negative sign goes to the positive 10x and makes it negative. The negative of a negative 4x is positive 4x squared. I'm sorry, 4x squared. And the negative of a negative 7x is positive 7x. The negative of a positive 11 is negative 11. So that's that same
Okay.
coming back that's going to be in math from now on until the end of time, because when we subtract, and I showed you an example of that with that little thermometer thing. All right, when you subtract across the zero axis, you're ending up adding. And it's just the way things work on the negative side. The negative side is sort of like a bizarro world. Everything's the opposite over there.
Okay.
So that's why that happens. Like I said, but that's not a new principle to hear. That's the same principles from chapter 1 and then chapter 2. We saw it with variables and like terms, and that's what we're doing here. We've just got more than a handful of terms. Well, we got 1, 2, 3, 4 different terms. We got the cube terms, we got the squared terms, we got the x terms, and then we got what they call the constant terms. So we just got to make sure we're subtracting from whatever is alike. And then we're applying that same rule. And like I said, this is the main one that people like here forget about, because when you're subtracting something, that's quite different from adding it. As I said over here, you could essentially just rewrite this without the parentheses. And just stack all these horizontally and then do what they do in that second step there. Because when you're adding, you're not changing any signs. Here, like I say, the parentheses do serve no purpose other than to show you that there's two different, terms there. I'm sorry, not terms, but two different polynomials. And then jump to this, and that kind of gives a little bit more explanation. But on this one, you're subtracting. Subtracting is different than adding. Subtracting is the opposite of adding. So you have to apply this negative sign to every one of those four terms. And then once you do that, it's just a matter of collecting like terms. And that's what they do here as they did up here. You're just putting the ones that are alike together, forming the math. Some of them are addition, some of them have got subtraction in it, and that's what you got. All right, now we're back to something on most of these that you should be able to type out. So I want y'all to work on 1 and 2. And incidentally, if you need to put a squared in, you can do this, or cubed even. You can do that. So go ahead and work on number 1 and 2. And like I said, pop your answers in the chat so I can click this little button on here for you to give you some All right. Well, that should be better now. I don't know why my PC keeps coming out. It's not PC, it's Chromebox, and this is it. All right. So, so that's those two. Now go on to number three. Go on to number three. And like I said, is you're just gonna have to put an x squared in like this. Oops. Or whatever the exponent is. So see, there's two are alike. And these two are alike. All I'm doing is just rearranging them. So that -7 and 2, so that's what. Anybody coming up with anything yet? -7 plus 2 is -5. Plus 3 is 9. Does that look good? All right, you can just keep on going. These are number 5. That's just addition. So down here is where we have to start changing the sign on the second ones. So just go ahead and keep going. If you see a problem with mine, let me know. Okay, I'm going to light them up. So there's those two like terms and those two like terms. So -12 and 3 is what?
-9.
Yeah, -9x squared. And then the constant terms are 5 and 11, which is 16 positive. So we need to, any questions on that? Going to number 5, if you don't have any questions. All right, now number 5 is a little tricky because not everyone has its own matching term. And it's in the, well, one's got 3 terms and the other's got 2. So something's going to be missing a light term. Let's see if we get somebody throw up an answer there. And all right, so let's look at this. Anybody come up with anything on it yet?
I'm having difficulties.
What kind?
Yeah, get it.
Like commit difficulties with the
Yeah,
with this? Okay, these are alike. And to just kind of put in what the up there, these two are alike. And then you got the negative 7x. And then there's not one like that, see, over here. And then these are alike. So that negative 7x is all by itself. So what happens on the other two? 6 positive, take away 8 is negative 2x squared. The negative 7x is just comes along because it does not have another like term. And then these right here, it's just 12, take away 4, which is 8, right? Right, it looks like you got it, Shanika. Okay, questions? We got plenty of time, so.
I must have added. I must have put the 6x and I must have added it. I didn't subtract it.
Yeah,
Because
well,
I got negative x squared 2.
well, it is negative. It's negative 2x. I'm not sure what you're saying, but I mean, if you add them, if that was a plus, it would be 14, but it's subtraction, so it's negative 2. All right, any questions about that one before we move on to the subtraction? All right, well, let's move on down there. All right, let's look at the subtraction. All right, so the subtraction is different like any other subtraction. You've got to apply the negative sign to anything on the right that's in that parentheses. So what I would do, just to kind of show you, I'm not going to do through the whole thing yet. X plus 9. I want to subtract the x and subtract the negative x. In other words, I'm doing this. It's supposed to be an 11. All right, you'll finish it up. Tell me what happens. Is that right, 20? What happens to the x's? See, these x's are opposite. That's a positive x and a negative x. So there's no more x's. So it's just 9 plus 11, which is going to be equal to 20. All right, good. Kenosha, where did you get that x at, Shanika?
Oh, it cancels out the X.
Yeah, a positive x
Okay.
and a negative x take each other out.
Okay.
All right, so over here, remember, the purpose of the parentheses here is a lot more important than it is when you're adding. For the adding, you can just drop it and it doesn't change anything. But this, it changes both of those terms. Now you collect like terms. All right, what happens with number 7?
You subtract the 7 from the 3, then it would be
Yeah,
3x minus 10 minus 2x.
okay, it's 3x and negative 2x there, negative 7, negative 3. Now I've got them close to one another, so it's a little bit easier to see what happens. So if you need to do that, go ahead and do it. Line them up, because it could be easy when you're doing it across to to line up the wrong terms with one. Okay. So what do we end up with? Is that right? X
I
minus
got
10.
x minus 10, yeah, 3x minus 10 minus 2x. And my step was 1x minus 10.
All right, looks good. Anybody else got that? All right, let me go through the rest of it now. All right, so that's 3x minus 2x, which is just an x. Negative 7, negative 3 is negative 10. So there we got it. Any problems with that?
Wait, what changed the sign in the second one?
Which
The
one?
negative.
Which sign?
The
Over
negative.
here?
Yeah.
Well, we're subtracting. See, this whole section here was adding. Now we're getting into the subtracting. Okay? See that? Subtracting, that's all it does is just change the sign. As a matter of fact, the definition of subtraction is addition of the opposite sign. Okay? So over here, notice that the sign is changing. All right, so go ahead and see if you can get it from there. So what happens with this one? See this one right here? That's the only one of its kind, so it does not have a like term. So it doesn't have one to add subtract to it, so it's just going to stay the same. All right, so and then these two are alike. -5, -4, so that's -9x. And those are alike, so that's -3, -3 is -6. Check it and see if I did that right.
Yeah, that's what I have.
All right, any last questions about that one? Anything else we want to get straight before we move on? Like I said, all of these from 6 on are subtraction. So that's why that sign is changing on the right. There's a distribution of this to all of the terms in there. Up here, distributing the plus does not change anything. Okay, it just means you're putting the things together, but that plus does not change the sign like the subtraction does. All right, so go ahead and try number 9 there. So my favorite thing to do first is just to change the sign of everything over there. That's the same subtraction we've been doing when we're doing distribution. When you're multiplying by a number, except here you're just changing the sign. It's like multiplying each one of these by a -1. See, so that's a positive 5x. So when we subtract it, it's a negative 5x squared. Subtracting a negative 2x makes it a positive 2x. Subtracting a 6 makes it a negative 6. And now, as I said, is you can put all the ones together to make it a little bit less confusing, like they did up here. See? I'm not going to use the parentheses. I'm just going to set them next to one another, so I can more easily see that. So those are the like terms. Was that cubed or that's, oops, you know what? Got to back up on that one. These are not like terms. Look at that. See, those are not alike. So that's got to stay by itself. So those won't put together, and no matter what we do. Now, everyone else, all of the other ones have another term like it. See this, the negative 6x, and then the plus 2x, and then the negative 2 minus 6. So what do we end up with? So again, these are not the same because that's a cube. This is a square. So no matter what we do, we can't put those together. They're not like terms. Negative 6 and plus 2 is negative 4x. And then negative 2, negative 6 is negative 8. Check it out for me and let me know. See if you see any problems with it. Does that one look good?
Yeah.
All right, well, I'm gonna assume everybody's all right with it. All right. All right, now this one's got 3 terms. I want y'all to work on it a little bit. Let me know how you're doing if you're struggling with it, and then I'll start slowly putting it together in a couple of minutes. See, what they've got is they're subtracting 2 different terms, okay? Here's the first one. When I say 2 different terms, it's not only 2 different terms. It's 2 different polynomials or binomials, or what they're called. So this one's going to come down That's not being subtracted, so it's just going to stay like it is. All right. But what we're subtracting is this one and then that one. You could really do this by just doing one subtraction, but they've got it broke up into two. So what happens on this one? So I got to, all right, let's see what's going on. Kim and the Cook, you got a good answer there. Minus a minus is a plus 5. And then again, we're minusing again, minus 7x. And then minus a minus 3 is a plus 3. And like I said is, we can now put everything kind of together. These two are alike. It's not the same over here where they were different. They're both x squareds. You got a 3x and a negative 7, positive 3x. All right, so see, these two are alike, these two are alike, and those two are alike. Anybody got any questions up to that point? Because you got to make sure you line them up right. So 2x squared minus 3x squared is just a minus negative x squared. Okay?
How get how did you get negative squared? Because I got the 4x plus 8.
You got what?
Maybe I missed the
4x?
step.
Well, you got
I had
2x
the
squared.
4x plus 8.
You got 2x squared minus 3x. Okay? Negative
Mm-hmm.
x, that's negative 1. 3x, negative 7x, and then 5 plus 3 is 8. So which one were you talking about?
No, I just missed the step.
Oh, okay.
I missed the at the big like the negative x squared. I missed the step.
Okay.
Can you just leave that up for a little while so I can write this,
Yeah.
please?
I got it.
All right. So anything, any questions at all about this addition and subtraction? Because we're getting ready. We're going to finish up the chapter today, so I got to move along, but I want to make sure we address anything here. All right, so here's what we're going to look at next, and this is really the last part of the chapter. Like I said, in a way, this stuff is easy because all you're doing is you're just using the concept of like terms. You're using the concept of like terms now with these things called polynomials. In other words, you got multiple terms with like x squared and x cubed and that type of thing. Generally speaking, that's going to be most of what you're doing. Now, let's see here. Let me bring up something to put here for those of y'all that missed this on Thursday. I showed this for the rules that we're using. It kind of condenses the rules. Where are they at? All right, so these are the exponent rules. We looked at division and we applied that because that's what 5.6 was about. And then all of the other ones we used within the context of 5.1 and 5.3, where we used all these other ones. Now, the one we're going to be concentrating on today is this one here again. All right, so just remember that if you have like variables and the exponents could be anything, they could be different, they're going to be a number. And the way that you simplify is you just take the common variable base and then you add them up. All right. In other words, let's see, I wanted to open up this one that had the, what was it at? I thought this was the one that had the example. Nope. It must have been the other one. Or I didn't put that one in there. Anyway. What's it at? Okay, here we go. So look at this third one. That's the one we're using there. Like variables, when we multiply them, we essentially add the exponent. So in other words, x to the 3 plus, times x to the 5th. It's just x to the 3 plus 5, which is 3 to the 8. Okay, so that's that rule refreshed there. Okay, so let's take a few minutes to go back. And that's the one we're going to be using here. But the thing is, every other rule is still the same as far as chapter 1 and chapter 2 in regards to the multiplying of numbers and signs and that type of thing. Okay. So let's look at this process. All right, so we got negative 4x cubed y squared. That's all one term there. And we're going to multiply it times negative 6x y squared. So what we're going to do is we're going to multiply now the x cubed on the left-hand side is multiplying times the x on the other side. So that's x cubed times x. 3 plus 1 is 4. Okay? And then the y squared times the y squared, 2 plus 2 is 4. All right, any questions about that?
Yes, can you repeat the second part again, please? Because you
Okay, well, when you say the second part, I thought that was all one part. So let's just
I'm
start back. You're multiplying negative 4 times negative 6. You're multiplying the x cubed times the x. You're multiplying the y squared times the y squared. That's just all the same kind of thing we used in that rule I just showed you that we went over there. Okay? That's that same addition rule. So negative 4 times negative 6, and this is wrong. They messed up on here. Negative 4 times negative 6 is positive. So it's positive 24. And then it's x cubed times x is x to the fourth. Y squared times y squared is y to the fourth. All right. So that's the whole process. Like I said, it's nothing really different. The only thing that's different is now we're applying these exponent rules. And in particular, we're doing this third one right here. All right. So back over here. Now, it doesn't matter which ones we multiply because we're multiplying several of these here. On this one, we got 3 terms we're multiplying. We're multiplying the 3x times the 2x. So they break it down here, showing you what you're multiplying, and the 3x times the negative 5x, and the 3x times the 9. And we're just following through. Like I said, the only thing that we've really got new to be concerned about is this rule right here, because that's the only thing that's new. Everything else is all old stuff. So 3x, or 3 times 2 is 6. X times x squared is x cubed. 3 times negative 5 is negative 15. X times x is x squared. 3 times 9 is 27, and you just got one x there. You don't have to worry about it. Okay? Now this is slightly different. I mean, not many people have heard of this, but when you've got, no matter what you're multiplying, you got to make sure that you multiply every term here times every term over here, but it's pretty easy because there's only one term. On this one, you got to make sure you multiply the 3x times all three. All right, that's why there's three multiplications. With this one, you got to make sure these two multiply these two. It doesn't matter on the order, but oftentimes people use what's called the FOIL. It's not really a method. It's just a way to keep track of which one to do. All right. In other words, this one right here would be called the first. This is the outside. This is the inside. And then the last are those. So that just gives you a way to be able to keep track of what you multiply by what. All right. So x times x is the first one, x squared. X times negative 3 is negative 3x. That's the first one's done. Then you're taking the negative 5 times the x, which is the inside, negative 5x. And then negative 5 times negative 3 is positive 15. Now, generally, when you do this FOIL stuff, then what you end up having is you have the two terms in the middle are going to be the like terms, so you collect those in the middle. Negative 3x and negative 5x give you the negative 8x, and you're finished. Okay? And we got a good bit of do on here, so let's get going. While you're doing that, so go ahead and give these a try. Hold on a second, I'll be right back. All right, so what happens on this one? All right, you got 4 times negative 5. And you got x times x. And there's no y to match over here, so it's just going to be the y is going to come along. So it's negative 20 xy squared. All right. So you see how you got that sign? Akimi, I'm not sure how to make you that
Yeah,
sign is important.
I forgot to put it in my bed.
Okay. Well, just as long as you got it on your work. I mean, when you type it in, you can make mistakes, but. So those two are together, and then you got the x squared times x to the 6th. Now, just to show you, because I think there's some people here missed Thursday, all right, when we went over this rule. Okay? This rule here that you add 2 plus 6. So that's really the only thing that's new here. All the other rules in mathematics are still the same. Okay? That's the only thing. When you multiply you add the exponents when you multiply like basis. All right. What about number 3? I'm just going to kind of line them up first. So see, they're all alike. See, these go together, and these go together. All right, and just to reiterate again, this is where we're at. So we're at midterm, all right? In other words, this exam right here is a major grade. All these other little tests, the regular little tests, small grades. This is a major test. So you got 2 days essentially. So make sure you're ready for it. There's a exam review in there. But like I said, it is 3 and 5 are the keys to this, chapter 3 and chapter 5. If you can basically graph, solve equations, and then use your exponents rules, I think that the midterm will be pretty easy for you. So what happens on number 3?
I got 72x to the 7th power, then y to the 12th.
Yeah, it's negative times negative, so it's 72. Again, x that's a 3 is what that is.
7.
Yeah. Okay? Is that what you said?
Yes, sir.
Okay, good. All right, any questions about that one? All right, now these are here, these are where you started to get into multiple multiplications. In each one of these, 4 through 6, you're taking one term and multiplying it times 2 or 3 inside the parentheses. So you're going to have 2 multiplications, 3 multiplications, each very similar to what you did up here. All right, so what's going on with this? It's going to be 3x. So there's the 2 multiplications you're playing. So 3 times 2 is 6. What do we got for the x term?
X squared.
Exactly, because it's x times x. So this is a 1 and that's a 1. You add those up and you got 2. This one, it's 3 positive times negative 7, so it's negative 21. And there's 1 x. Yeah, good. Go on to that next one. We should have plenty of time to finish this. Like I said, I'm just a little bit concerned because I got to run to City Park, like I usually do. So 6x. So the negative 9x is multiplying both of these.
Negative 4
Mm-hmm.
x squared.
X squared, good. Negative what?
45
And just
x
1x. All right. Now on none of these 3 here through 6, you won't have anything that's going to combine But starting in 7, you're going to end up having the ones that do that. Okay, so go ahead and do this last one here on number 6. If you want to, you can go on to number 7 through, but
Mm.
all right, so that's all multiplying this one. We're going to have a hard time squeezing it in here. So I'm going to have to write small and may have to go to the next line, but this is what we're doing. We're multiplying 3 times. All right, so what happens on this one?
X squared Q.
All right, on this first one, what are we multiplying? We got a 4 times a 2, right?
Mm-hmm.
So that's 8. You can't forget about the numbers. We got squared and x, so that, yeah, that's x cubed. And then y cubed times
Hey, what
y.
I said?
What's that?
Never mind. Go ahead.
So see, 4 times
12
2 is
X.
8. X squared times x is x cubed. Y cubed times y is y to the 4th. And then here, 4 times, I'll tell you what, I can, it's going to be negative. Let me make that a negative sign. So positive 4 times negative 3, so that's negative 12.
X
Squared
Q.
times x is x cubed, good. And then the y term does not have
Y
anything to
Q.
multiply, so it just stays the same. And the last one is a positive term. 4 times 4 is what, 16?
16.
The square x does not have anything on the other side, so it's just
Squared.
gonna, and then this is y cubed and a single y. All right, any questions about that one? I mean, that one is a long one, and it's kind of messy because it's got 3 things you got to multiply in each one. I mean, you got the numbers, you got the variables. So, all right, and in each of these, as I said, these are all those first, outside, inside, last. All of these up until this last one. All right, so try 7, 8, and 9. I'll give you a few minutes. All right, and these are what we call binomial times a binomial, and for the most part, what you end up getting when you multiply them is you get what's called a trinomial, because there's 4 terms, but 2 of them are going to combine. So that's first. All right. So what happens on this? Let's see. X times x is x squared minus 7x, good, minus 44. All right, any questions about that one? Okay, all up until number 11, these are all going to be done the same way. Now, incidentally, you don't have to go in that order, but the reason why people use that is just because it kind of makes it easy to remember, the order and knowing which ones you're going to multiply times which. So again, this is first, outside, inside, last. Well, that storm came up quick. Did anybody here get any trouble with water or anything?
No, it didn't even pass by where I stayed.
Yeah, I know.
That's it.
I don't know. It was strange how it did. It was like almost never seen something come up so quick, but it really wasn't that much to it. But some people got flooded. I think it was because it was pushing in water, so the water couldn't drain out. All right, so this is X. So that's the first. The outside. And the inside. Making this too long, but so what do we got? X times X is always X squared. And then that's just 2 times 1 is all that is. X times -9 is -9x. And then this is negative times negative, so that's -63. And as I had said, yes, with these binomials, you're always going to have 2 in the middle that's going to combine. Now that's, if you have some that's got, like one's got an X and one's got a Y, it won't do that. But generally, most of these, all of these will. You're going to have those 2 middle terms. That's a negative sign, not an equal. There we go. All right. All right. So this one right here, again, is this times that times that, this times this. So I'm going to put it down a little bit lower. So 3x times 2x. Three x times 3. Seven times 2x plus. All right, good. Let's see what we got. 3 times 2 is 6. X times x is x squared. And then you got 9x. And then this is 14x. 7 times 2. And then 7 times 3 is 21. All right, anybody got any problem with that? Looks right to me. All right, let me give you a little bit of help with this one. Now, this is what we call here, this 10. It's called the difference of squares. And it's not so important to know that term. It's just if you understand the principle behind it. And basically it works like this. And I'll just use, if you got x plus y times x minus y, that what happens is you simply end up with x squared minus y squared. And you can find that out by going ahead and doing your FOIL, but that's an easier formulaic way to do it. Okay. So go on to number 10. And this one is like that as well. Both of these are. And then 12 and 13 follow another pattern. And again, it's not so important that you know the pattern, but the pattern can save you some time and trouble. So if you just follow the same old pattern, we got x times x plus 3x minus 3x, and then minus 3 times plus 3. So what that ends up being is x times x is x squared. The plus 3x and the minus 3x, they take each other out. They're the opposites. So all we're left with is just negative 9. And that's what I mean by the difference of squares. When you multiply that, those things that fit that pattern, then all you need to do is you square the first term, square the second term, and then put a negative sign in the middle. So try that one, and then I'm going to work it the short way. All right? All right, what happens with number 11? So see, there's a 3x in both places. So that means we're going to multiply 3x times 3x, which is 3x squared. See, these are opposite signs. So this is a negative 7y, and this is positive 7y. So we put the negative sign there, and then we just square this term. And then that's using, which rule was it? This one here. Right here. Both of these are pretty much the same. The ones there, it affects anything inside the parentheses when you bring it up to that. So you're squaring the 3, which is 9, and you're squaring the x, which is x squared. Over here, you're squaring the 7, which is 49. The negative sign is still there. And the y. All right. This one here is called the sum of squares. Oops, the sum of squares. And it's basically this. It's a little bit more complicated, But basically it's this. If you square a binomial, you're going to have this pattern here. And the only way I can kind of prove this to you is just to go through the FOIL and see it. And I think at some point you'll realize that after you've done it enough, and it might dawn on you and say, hey, why am I taking this long way around when I can take this pattern? And it doesn't matter if it's negative or positive. If you got a negative sign in there, same thing's going to happen, except that that middle term is negative now. So let me show you what I mean. And I'm going to go do this one. I'll have you come back and do number 13, because that's the easier one. All right. So when you FOIL it out, you got 4x. Oh, and let me rewrite this. This means 4x minus 9 times 4x minus 9. That's all that squared means. It means multiply it by itself. So 4x times 4x. That's the first. The outside is that's the outside, and the inside is really the exact same thing. And that's why this works, because that's what that 2 represents. You're going to have 2 of these. And then the last is negative 9 times negative 9. So that's going to be 4 times 4 is 16. X times x is x squared. On the inside, it's 4x times negative 9, so that's negative 36 x. And again, you got another one exactly the same. And here, it's negative 9 times negative 9, which is positive 81. And again, that's why this works. That's why that has that 2 in the middle. If this is a positive 7, then you're going to have 2 of the terms. Even if it's negative, you'll have negative 2 of them. All right, so go ahead and try number 12. And then 14 is kind of like, and yeah, it's kind of one you're going to have 6 multiplications. So like I said, I'm going to use the formula up here. Okay, good. So it's x squared. I'm just following that top one. Plus 2 times x times 7. So that's 7x plus 7 squared. So that's going to be x squared plus all right, any questions about those? Like I said, we just got one more. I'm going to let you work on it, and then that'll be your ticket out of here today. Get us out a little bit early than usual, because I need to get something to eat before. And I barely get over there, not enough time when I leave at 1, so taking that break at the end here.
This is not a question related. I just wanted to tell you that
What's that?
Wednesday. I said this is not unrelated to the Mac answer or whatever. Wednesday and Thursday, um, I couldn't log into the computer because it kept asking me for my password. So I called it like 1-800 number, and they told
Mm-hmm.
me y'all it was down.
Well, it was
I
down for
ended up
about 40. Yeah, it was down for about right before the beginning of class, and we ended up and had class. Yeah.
But me, I couldn't log on until I think it was Saturday.
Hmm.
I think Saturday, or so I had to end up calling them back again because it refused not to let
Well,
me
let me
in.
show
So
you how to do this in case you ever, because you don't have to go through Canvas. Look at this. When you sign up for My Math Lab, you got a My Math Lab account.
yeah.
Okay, so this is what you do. You go to Pearson, www. See here? And then you can log in there. And that leaves out a step. You don't have to go through Canvas.
Okay, and it would bring me straight to your class. If that
Yeah,
was
the
to
My Math
happen
Lab.
again.
Yes. If that ever
All
happens, because
right.
you know this is accessible.
Okay. I just had wanted to let you know that to make sure that I never dropped out or anything else.
Yeah. So just keep an eye. I'm going to go back to that problem in a minute, but just remember, this is the midterm, coming up here. We're finished all of chapter 5. Tomorrow we'll be reviewing. I'm going to have that midterm open, and it'll be opening up until Wednesday night. Now, you got to realize with things like midterms and final exams, they don't extend these things because I got one day to get all those grades in, and those grades aren't binding at midterm, but they show you where you stand at. And then that midterm is very important as far as grade because that thing is 25%. All right. So that will take the place of any missed or low test grade. All right. But that one, you got to make sure that is a major, major test grade. It's very hard to pass without the All right, so with this one, there's no real mnemonic on it. You just basically got to, and so just remember, you got a midterm review inside My Math Lab. You got one inside here. All right, both places. So let's go ahead and finish that up real quick, and then I'm going to get out of here because, like I said, I really got to get something to eat today. All right, so first is 3x times 5x squared. It's going to be rather long because I'm showing you all of these little pieces. It's plus 3x times negative 2x and then 3x times 6. All right, so there's the first 3 for 3x. Plus, or we can just put -2 times each one of the 3. I'm sorry, that -2 times 5. So there's all 6 of the terms. So 3 times 5 is 15 x cubed. 3 times -2 is -6x. And then this is positive 18x. And then this is negative 10x squared. -2 times -2 is positive 4x. And -2 times 6 is -12. Are there any things that are alike there? There should be. This was a cube, so and that's a squared. But these are alike. That's alike. So we're just going to put those together. All right, so that's plus 12. I'll put the other one in a second. There's no match to the x squared term. And then the plus 4x. So that's 4. That's back to 16x. Well, I'll tell you what, let's put in and put this one down. You should always have them in ascending order or descending order, they call it. Okay, so there you go. All right, any last questions? All right, so tomorrow's review for our midterm, including chapter 5. So make sure you bring any questions you got about anything. Like I said, there's a review in there. Everything's in those modules.
Okay.
All right, see you tomorrow.